water cycle is the adventurous journey that water takes through the oceans, atmosphere, and land, driven by the sun.
Water simply doesn't go away, but travels as a liquid, solid, and gas in an endless loop known as the water cycle. There are 4 parts of the water cycle: evaporation, condensation, precipitation, and collection. Evaporation occurs when the sun heats up the water found in lakes, rivers, or oceans and turns it into vapor. Condensation is when the water vapor in the air cools and changes back into a liquid, forming clouds or water droplets. Precipitation is when clouds release water, usually as rain or snow. Collection happens when water from rain and melted snow accumulates in streams and rivers and flows back to the ocean. Then the cycle begins again.
Looking at our Earth from space, with its vast and deep ocean, it appears as though there is an abundance of water for our use. However, only a small portion of Earth's water is accessible for our needs. How much fresh water exists and where it is stored affects us all. Nearly 2/3 of this fresh water is stored in the polar ice caps, snowpacks, and glaciers, making it inaccessible for long periods of time. The water cycle is dynamic. It describes the continuous movement of water on, above, and below the surface of the Earth, and the transitions from one state to another. Sea surface temperature, surface winds, and air temperature influence the rate of evaporation at the ocean surface. In the tropics, warm ocean surface temperatures support high rates of evaporation. Wind also increases evaporation. When the air's temperature is warmer, it can hold more water. While the atmosphere does not store a large quantity of water compared to the ocean, rivers, and lakes, it can transport water quickly from one place to another. Low-lying regions of the atmosphere with high moisture and strong winds can form atmospheric rivers to transport water horizontally. Clouds are formed as water vapor cools and condenses into droplets and ice crystals. Clouds and water vapor act as insulators in the atmosphere. Clouds help shield the Earth from the sun and trap heat from below. When cloud particles grow large enough, they may fall out as rain or snow. Under the right conditions, areas of precipitation can grow into large storms. As storms grow, they transfer heat vertically into the upper atmosphere. The migration of storms helps to distribute heat between the equator and poles, shaping wind patterns globally. How storms grow and intensify depends on atmospheric moisture, surface temperatures, and wind patterns. Precipitation is concentrated in some parts of the world and scarce in others. It can vary substantially from season to season and from year to year. Water that falls on the land surface as precipitation is stored within snowpacks, lakes, reservoirs, soils, and underground aquifers. Water availability varies from place to place and over time. The availability of water affects the type and abundance of vegetation, the primary source of food for animals and people. Extreme water cycle variability, unusually dry or wet conditions, impacts humans worldwide. Each year, hazards such as floods exact a costly economic and human toll. Most of the water that falls onto land remains stored there for weeks or more. Snowfall is stored as snowpack or ice. Meltwater and rainfall are stored in lakes and soils. Some of the water is absorbed by plant roots or drains into the water table. Eventually, the water will evaporate to the atmosphere or return to the ocean in streams and rivers, providing a source of nutrient-rich water that supports ocean life.
The global water cycle keeps our planet alive. The rivers are its arteries. Rivers run down mountains through forest, flow through desert and delta, course through bended bay and swerving shore, and recirculate back from our ocean. Evaporation, condensation, precipitation. Access to water has defined where human populations have flourished.
People also have a role in the water cycle. By pumping water out of the ground for irrigation, cutting down forests for development, and building roads and other concrete surfaces that lead to runoff, people can have a serious impact on the path a water molecule takes.
Now we are changing the carbon and nitrogen cycles. We are altering the global water system too, through damming, extraction, irrigation, and climate change. Many rivers no longer reach the sea. We move more sediment than natural erosion and rivers. We've built 48,000 large dams. We've drained half of global wetlands. We use an area the size of South America to grow our crops, an area the size of Africa for our livestock. Agriculture accounts for 70% of global freshwater use, and we need to feed a growing population. In a single lifetime, we've become a phenomenal global force. We're pushing Earth into a new geological epoch, the Anthropocene, dominated by humanity. We have altered Earth's snow cover, sea ice, and ocean volume, fundamental elements of the water cycle. Climate change will bring more flooding, drought, and disease. A warmer atmosphere holds more water vapor. This is causing the water cycle to intensify. Wet regions are becoming wetter, dry areas drier. Rainfall patterns are changing. Damming, mining, and extraction are causing 2/3 of major deltas to sink. Almost 800 million people have no safe drinking water. 2.4 billion remain without adequate sanitation. 1.7 billion people live in places where groundwater is being extracted faster than it can be replenished. 4 out of 5 people worldwide face risk to their water security. For water security for all, we urgently need innovative and creative approaches to policy from local to global. With nations competing for limited resources, we must find better ways to manage them. And we must adapt to a changing water cycle. This is the challenge of water in the Anthropocene.